The year is 2099. Humans have been traveling in space for 150 years. Every part of our solar system has been explored. Missions to the nearest stars are on their way. But space travel has proved hazardous for human beings. And death lurks in the hostile environments of the planets and their moons. And so, through human ingenuity, a new breed of space explorer has been perfected. These are the SIMs, 5 super intelligent machines capable of operating in the most extreme and threatening conditions. Earthlink, the mighty spaceship which carries them across the void. On board is Lander, the transfer vehicle and sanctuary while on a mission. Inside are Legs, who tackles the most dangerous terrain. Wheels, the roving scientific detective. And Hover, the rescuer and scout. This team of trailblazers acts as agents for the human race, adventuring far into the solar system and beyond. Their destination, space. The SIMs voyage to explore Saturn and its rings in the year 2080. Most beautiful of the planets, with its magnificent rings, Saturn also has 9 substantial moons and many small moonlets. On this mission, the SIMs launched probes into Saturn's windy atmosphere and sampled the ice and dust in the ring system. Their main objective was to discover the origin of the rings. Using a small moonlet orbiting within the ring system as a base, they would employ cutting-edge technology to avoid disastrous collisions.
We're off to Saturn. Is there any other planet in the universe so beautiful?
Very probably, Legs. But in our system, there's nothing quite like Saturn, even though other planets have rings of a sort.
We're landing on a moonlet inside the rings. It could be deep in fine dust, as well as having next to no gravity.
At least we know that the microgravity equipment being prepared for us has been improved since our trip to Halley's Comet.
Saturn mission at T-90. Traffic control go. Earth tracking stations go. West Atlantic recovery go.
All positive. We're clear for takeoff. We have ignition. And rolling. V1, V2, rotate. Airborne and climbing. Our next challenge will be to dodge the rocks in Saturn's rings.
Lander will be fitted with rapid response radar for that. Its fuzzy logic computer can program a safe passage in just a nanosecond.
All theory. Bet I end up having to do some ace flying.
Mission to Saturn's rings, docking at Port 7. Install Lander's new radar system for guidance through the minefield of obstacles in the rings. Microgravity environment kits needed for all SIMs. For EVA in the rings, hover is to be modified with the multi-layer ceramic outer casing.
With that reinforcement, I can just brush aside the smaller rocks in my way. This is going to be like our mission to the comet swarm 15 years ago, only 100 times more dangerous.
And 18 years ago, we were floundering around in the microgravity of Halley's Comet.
Both missions were good training for this new challenge at Saturn. Here's some background from the archive.
Saturn, known since ancient times, is the sixth planet from the Sun, a giant more than 9 times larger than Earth. Soon after astronomical telescopes were invented in the 17th century, observers spied the surprise ring system for the first time. The French astronomer Cassini discovered the widest of many gaps in the rings. The rings are 170,000 miles in diameter, but very thin. Every 15 years or so, they are viewed edge-on from Earth. At this time, they cannot be seen because they're only a few hundred yards thick. The rings are not solid, but a collection of countless icy particles, rocks, and boulders.
The other giant planets in our solar system have rings, but none so fine as Saturn's.
I'll stay a mile or so above the rings, out of danger. Lander will search for a suitable base. There are many moonlets a couple of miles or so across, lurking in those narrow gaps.
The Voyager spacecraft discovered Jupiter's scanty rings in 1974. The main ring is just 20 miles thick. There are much fainter rings closer to Jupiter. Voyager glided past Uranus in 1986 and captured images of its faint rings, first discovered 9 years earlier. Uranus has 9 very slender rings, each about 2 miles wide and just 100 yards thick. Then Voyager pressed on to Neptune. There, 15,000 miles above the cloud tops, it saw another system of faint planetary rings.
From that archive, only Saturn's rings look dangerous. But the engineers say a baseball going at 100 feet a second would bounce off my new casing. I can't wait to give it a try.
You have to launch these mesocopters into Saturn's atmosphere. As they descend, they will transmit data back to me on temperature, chemical makeup, and wind speed. Engineering complete. We'll leave the space station after one more orbit of Earth.
Once at Saturn, the SIMs will try to solve a major scientific puzzle. Just how did Saturn acquire its rings? One theory suggests that long ago, a moon of Saturn orbited so close that gravity tore it to bits. Another says that the rings may be debris from comets that almost collided head-on with Saturn. Or the rings could be matter left behind when the main planet formed.
We'll crack that problem by seeing exactly what the rings are made of and how old the fragments are.
Legs, set a course for Saturn the Beautiful. Let's explore its weather and exotic rings from close up.
Course set. Ion drives programmed for 3 milli-G.
Under the steady acceleration of the immensely powerful ion drives, Earthlink would be halfway to Saturn space in only 5 months.
Velocity 100,000 attained and increasing steadily.
We first pass Mars's orbit and then Jupiter's. Saturn is 10 times farther from the Sun than Earth, but our trajectory gets us there as fast as possible.
Velocity 200,000.
There's another fascinating property of Saturn's rings. They have moving spokes.
Mysterious dark waves travel over the rings. These may be opaque dust swept around in a spoke-like pattern by Saturn's magnetic field.
Lander, your primary objective is to select a moonlet in the rings to act as a base. Some of them keep the rings in place, others sweep out gaps. You need to find a suitable one.
From the moonlet base, I'll fly to Saturn to launch the mesocopters.
Saturn, second largest planet in the solar system, has nearly 100 times Earth's mass. It spins in a little over 10 hours so fast that it bulges at the equator. Most of its bulk is made up of hydrogen. Saturn is so light that it would float on any water ocean big enough to contain it. Saturn's cloud belts are hazy, but they are driven by the most violent winds in the solar system. Raging storms cause large white spots to appear. When an enormous bubble of ammonia bursts up through the clouds, it can rapidly spread, sometimes all around the planet. The first investigation by a spacecraft was back in 2004. The Cassini orbiter made many close passes over the cloud tops and rings.
We have a problem. The portside ion drive has just died on us.
I can check it out, but we'll need a troubleshooting link up with mission control.
At this distance, Earth takes 40 minutes to respond.
Shutting down starboard ion drive.
However, it's safe for EVA. Make external examination and report back.
Launching now. Closing on port side nacelle. I'll line up along the main axis, then move in for a detailed view.
Give me high res of the final drive magnetic coil.
That's online now.
How about the beam focuser?
Confirm situation nominal on beam focus.
Hover return. I am reading all hardware satisfactory. We've got a software problem with ignition.
I'll check the electronic circuitry. There could be a component failure higher up the chain.
Mission control is working on it, but radio contact between us and Earth is eating up 40 minutes every time we exchange data.
We're going nowhere fast. We could use the Omega main drive.
No, we need to hold our chemical fuel in reserve. Mission control reports that ion production software has a baffling fault. They could take a week to solve it. We do nothing meanwhile.
A week? We'll have fallen too far behind on our flight path to make the rendezvous with Saturn.
We've lost 10 million miles, so here's a revised plan. We'll use the reserve tanks for the Omega engine to strike a course for Jupiter.
At Jupiter, the hydrazine thrusters will position us for gravity assist.
And by then, Earth should have patched the ignition. And we can still reach Saturn on schedule.
Sounds good, but the margins are tight.
Main ignition sequence commenced. Programming 38-minute burn.
Still no software fix from Earth.
Perijove in 6 seconds.
Successful gravity assist at Jupiter.
The next problem to solve is cutting our speed. We are now going too fast to enter Saturn orbit.
Yesterday's download failed. I'm about to go online for another try.
It's our only chance. If we lose another day, we can't slow down enough. We'll crash into Saturn.
If this retro burn fails, we'll abandon Earthland. I can get us down safely on some moonlet. That would be a suicide mission. We'd never get back to Earth. We can be replaced, however. The science must get done.
Software coming through now.
With just minutes to spare before the Saturn acquisition window was lost, Earthlink rotated for a retroburn to slow the approach.
Stand by to fire Omega rocket.
We have ignition.
Start both ion drives.
Success. They're working. Program for 20 millig's.
And 10-minute rocket burn. That will use up all the reserves.
Altitude 10 miles above the ring plane.
Look at those ringlets.
Moving down for a closer view.
Rock search and avoidance radar engaged.
Radar is registering an uncharted moonlet ahead, 1 mile across. Go for landing.
Stand by for launch. Avoidance radar on. Fuzzy logic computer on. I'm locked to target moonlet. I read suitable surface for landing. What's going on? The altimeter is giving a confusing reading. But I cannot abort now. We are committed to a landing. Touchdown imminent. What a thump. The surface was nearer than indicated. I came in too fast. We've sunk a couple of feet into the surface.
There's next to no gravity here. But for the pads on your feet, Lander, you would have bounced straight off.
Anchor down. Let's get to work.
Ice and dust is falling like gentle rain. What's the ice made of? I read a surface temperature of minus 270 degrees.
I'll start the analysis.
All you've picked up so far is dust and ice falling from the rings. I've located a dark rocky outcrop over here.
In our location, the surface ices are mainly water, with some methane and ammonia. There's some contamination from dust as well.
Water ice? That could mean the material has come from the comet swarm. What do you make of this, Lander?
The chemical makeup is certainly just like the pristine comets we visited back in the 2060s. And the giant planets Jupiter and Saturn capture new comets. Here's Shoemaker Levy, the famous one that hit Jupiter almost a century ago. That one slammed into the atmosphere. But maybe at Saturn, the infalling comets sometimes get shredded up in the rings. Hover, you are go for the Saturn atmosphere excursion to examine those high-speed winds. Wheels, get the chemical makeup of the rocky outcrop. I'm on my way.
As Hover sets off, an unwelcome visitor approaches the moonlet.
Whatever this dark rock is, it's not ice. I'm reading a density 3 times that of water.
It's slightly magnetic. It could be iron and nickel. Let's see. It's a solid metallic mass.
Composition is iron and nickel. It is metal with mineral crystals inside. That could mean this moonlet is from a much larger moon that disrupted long ago. Alert! Radar picking up a boulder coming in at 3 feet per second. Range 400 feet.
We can't run for it untethered down. And even if we tried, we'd just leap helplessly into space.
Look at that! Oh, it bounced clear.
We could be under the impact point of the next one. Let's have Lander get us out of here.
Take it steady, Legs. I can't pick you up while I'm bogged down. And, in any case, I'm fully stretched, logging Hover's progress. I'm 300 miles above Saturn's cloud deck. A great white spot is raging away. It's a chance to explore warmer gases bubbling up from below. Launch procedures commenced. The first mesocopters are now deep in the white spot. I read pressure 11 atmospheres, and the temperature down there is as warm as on Earth. No oxygen, mainly hydrogen and stinking hydrogen sulfide. Wind speeds 1,300. The first mesocopters have destructed. I'll launch the second batch. Lander, I'm returning. I'll fly through the rings to get more data. This is like a snowball fight. Everywhere in the rings, it's a mix of rocks and ice. That rock was like a baseball. I just registered a bigger hit. There's metallic debris. Thruster jets knocked out, port side. Starting D-spin procedure with starboard thruster. Lander, do you copy? We copy you. I'm stabilized now. Remain at your location for rendezvous. With one thruster knocked out, you cannot navigate. I'll be with you as soon as I can get free. More power. And again. Success. I'm on my way. Hover detected. Range 6,000 yards and closing. The radar and fuzzy logic will see Hover as just another lump of debris. They will go into avoidance mode and guide us away from him.
Radar off, manual engaged. I said I'd end up doing ace flying. Hover, I am vector locked and closing. You did a nice job controlling that spin with one thruster.
Nothing like imminent oblivion to focus the circuits. I have you on visual. We are lined up and closing. Welcome aboard.
Avoidance radar on. Fuzzy logic computer on. Let's get to Earthlink. Radar detection of density wave. Remember those dark spokes in the rings? One is sweeping towards us. We need to get above the ring plane.
They're reporting from Earth that we may have solved the mysteries of Saturn's rings. And Hover's data from the Great White Spot has got the meteorologists excited. Time to return to base.
The SIMs had found water ice, rock and metal in Saturn's rings. It seemed that the ice had been brought by comets, while the rocks and metal were the remnants of a moon that broke up billions of years ago. A major step had been taken in solving one of the oldest mysteries of the solar system.